What up, algebra nerds? Today we're going to look at solving a system of equations by using substitution. So we've already started working with systems, but we solved by graphing. When we graphed, we realized that the solution is actually a point of intersection of two lines, or two or more lines, and the solution is that point, those ordered pairs, or that ordered pair. So now we're going to look at solving a system, but instead of graphing, we are going to use substitution. Substitution isn't anything new. We've used substitution a lot in math. You substitute numbers in for variables all the time. So let's see how we're going to use it here. Alright, so I look at these two equations. This makes a system, two or more equations. And I notice that the first equation says y equals 2x plus 1. So it's telling me that y is the same as 2x plus 1. So I can come down here to this second equation, and where y is, I could simply substitute in 2x plus 1. That's the substitution part. So that's what I'm going to do. So I'm going to rewrite this second equation, x plus 3, but instead of putting y there, I'm going to put 2x plus 1, because y equals 2x plus 1. They're the same thing. And then that is equal to 24. Right now I'm going to distribute. 3 times 2x is 6x. 3 times 1 is 3. I'm going to collect like terms. 1x plus 6x is 7x. Now this is just a simple two-step equation. Inverse operation. Subtract 3 on both sides. Divide by 7 on both sides, and x equals 3. So I have the first part, I have the x coordinate, I have 3, but I need the y coordinate in an ordered pair. So now I take this x equals 3, and I could substitute it into either equation where x is. Okay, now I'm going to use the first equation, doesn't matter which, but since the first equation says y equals, and I'm trying to find y, it makes sense to me to use that one. So y equals 2 times, but instead of x, I'm putting the number 3, since x equals 3. So y equals 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. Therefore, my y coordinate is 7. And then that's my solution. The ordered pair, 3, 7. Alright, let's try another one. This one's going to be a little trickier. The first problem that we looked at, it was set up y equals. So it was easy to substitute. Or if it would have been set up x equals, that would have been easy too. This one isn't set up that way. Neither equation says x equals or y equals. So I've got to get one of them to say that. And it's a matter of which one's going to be easier to set up that way. And I think this first one is going to be easier because I already have a 1x all by itself over here. So how can I get this x by itself? We've had problems like this year where we've had to get one variable by itself and there was more than one variable in the equation. So I'm going to use inverse operations. I'm going to add 2y to both sides. So that cancels. X equals 2y minus 7. So now I have it. X equals 2y minus 7. So I can come over here and where x is, substitute in 2y minus 7. So that's what I'm going to do. 3 times 2y minus 7 and plus 2y equals 3. Distribute. 6y minus 21 plus 2y equals 3. Combine some like terms. 8y minus 21 equals 3. Add 21 to both sides. Let's come over here. 8y equals 24. Divide each side by 8. And y equals 3. So I have my y coordinate is 3. I still need my x coordinate. So I can use any of the equations. I can use this one. I can use this one. Or I could use this one. And since x is already set up over here, x equals, I'm going to use this one right here. So I'm going to say, do it in blue here, x equals 2 times y, which we just found out is 3, minus 7. 2 times 3 is 6. 6 minus 7 is negative 1. So our x-coordinate is negative 1. Negative 1 comma 3. Alright, let's do another one here. Alright, once again, neither of the equations are set up x equals or y equals, so I've got to now get one to be that way. Well, none of the variables have a 1 in front of them. That's like the first thing I look for. That makes it easier. So now I got to figure out, well, which one of these equations am I going to be able to get rid of that coefficient? You know, whether it's the 4 here, the 2 here, the negative 3 there, or the negative 5 there. Which one am I going to get rid of easily? And I think it's going to be this 2, because when I end up dividing by 2, this number is divisible by 2 and this number is divisible by 2, so it's going to work out perfectly. So let's take this 4x plus 2y equals 8, and let's solve for y. We'll subtract 4x on both sides. That cancels. 2y equals negative 4x plus 8. We'll divide everything by 2. Y equals negative 2x plus 4. So now we have it. Y equals negative 2x plus 4. So I can substitute that negative 2x plus 4 in for y in my second equation. So negative 3x minus 5 times negative 2x plus 4, because that's what y equals. We just found that out. Equals negative 13. I'm going to have to do some distributing here. So negative 3x. This minus 5 is the same thing as plus negative 5. So plus negative 5 times negative 2x is 10x. Plus negative 5 times 4 is negative 20. Equals negative 13. Let's combine some like terms. Negative 3x and 10x is 7x. This plus negative 20 is the same thing as minus 20. Two-step equation. Let's add 20 to both sides. And I'm going to come over here. 7x equals 7. Divide by 7. X equals 1. So let's see. So far I've got the x-coordinate as 1. So now I'm going to substitute that 1 in to any of my equations. I can substitute this equation for that x. I can substitute there, or I can come back and use this one and substitute it in there. And I think that's what I'm going to do. Let's do this and erase some of this stuff. Give me some room here. And let's see. Let's get rid of this here. Alright, make that a little nicer. Alright, so now we're going to take y equals negative 2 times x, which we just found out is 1, plus 4. And negative 2 times 1 is negative 2. Negative 2 plus 4 is 2. So my y value is 2. So there's my answer, the ordered pair 1, 2. Don't forget, you can check them by plugging the x and y values into both of these equations and seeing if it works. Alright, now you get 2 problems for you to work on. So pause the video, try them, go back and watch me do them. Alright, so this first one, it's already set up y equals 5x plus 7, so we'll substitute all that in for that y. 5x plus 4 times 5x plus 7 equals 2. Let's distribute that 4. 20x plus 28 equals 2. Collect some like terms. 25x plus 28 equals 2. Well, I just realized I wrote something down wrong. This was 5x minus 4y. I wrote a plus here, so let's just fix that. Should have been a minus. That should have been a minus, which would have made, I guess these, yes, negatives. And then, let's see, this would be negative 15. This 5x minus 20x would be negative 15x. Alright, we're okay now. Alright, so two-step equation, subtract 28 on both sides. And we get negative 15x equals. Nope, let's see, I messed up again. Forgot to copy it down here. My bad. Alright, let's fix this. Remember that was a minus. I changed it up there, so these will be pluses here. So I'm going to get a 30 there. Alright, I'm going to divide by negative 15. Don't worry, we'll get there, guys. And I get a negative 2. So far I get a negative 2 for my x-coordinate. I'm going to plug this into either of the first two equations. I'm going to choose the first one. Y equals 5 times. I'm going to put negative 2 in for x, plus 7. 5 times negative 2 is negative 10. And negative 10 plus 7 is negative 3. So, negative 3 for my y-coordinate. Negative 2 comma negative 3. Hopefully you got the same. Alright, pause it, try it, come on back and watch me do it. Alright, so here I got to pick one of these equations, and it looks to me like I could actually use either of them. And I'm either going to use the first one and solve for x, because everything here is divisible by 3, or I could use the second one and either x or y. Doesn't really matter. So I'm just going to go with the first one. 3x plus 9y equals 3. I'm going to solve for x, so I'll subtract 9y on both sides. Negative 9y plus 3. I'm going to divide by 3 on both sides. Negative 3y plus 1. Alright, so now I'm going to take that and substitute it into the second equation where y is. So 2x minus 2 times. No, I'm sorry, I'm substituting in for x. My bad. Wow, I'm just all kinds of mistakes here. So we're going to substitute it in there. So 2 times negative 3y plus 1 minus 2y equals 10. And we'll distribute negative 6y plus 2 minus 2y equals 10. Let's combine some like terms. This is the same thing as plus negative 2y. So negative 6y plus negative 2y is negative 8y. We'll just subtract 2 on both sides. Come over here. Negative 8y equals 8. Divide by negative 8. And y equals negative 1. Alright, so I have my y-coordinate negative 1. I'm going to substitute that negative 1 in for y. I can do it there, there, or I can do it right there, which is the one I'm going to use. So let's take x equals negative 3 times y is negative 1 plus 1. Negative 3 times negative 1 is positive 3. And 3 plus 1 is 4. So my x value is 4. And then once again, if you want to just be 100% sure, plug these in to both of the original two equations and see if it works. Alright, good luck guys solving systems using substitution. So that's, we learned how to solve graphing, we learned how to solve substitution, and then we're going to learn a couple other ways after this. Good luck.